Good afternoon. It is June 19th, 2018. Now, for this segment, we're going to talk a little bit about the recent NASA Global Temperature Report for May of 2018. And what we find that, according to NASA data, is that the Earth overall was about 0.82 degrees Celsius above the NASA baseline 20th century average, and that translates to about a little bit more than 1 degree Celsius above 1880s averages where the NASA measure starts. So overall, in this 138-year climate record, May of 2018 is coming in as the fourth hottest on record, with 2016 as number 1, 2017 as number 2, and 2014 as number 3. Overall, May of 2018 beat out every other single year, and this despite the fact that La Nina conditions were starting to fade in the equatorial Pacific, but we're still maintaining a bit of an influence on global temperatures, which would tend to keep global temperatures cool. Now, looking at NASA's global graphic, we find that the warmest global temperatures occurred from an anomaly standpoint. Now, this is an anomaly graphic, which measures temperatures as they depart from average. So where you see blue, it was cooler than average, and where you see yellow, orange, and red, it was warmer than average. And as you can see, most regions of the world experienced warmer to much warmer than average conditions. Now, the regions that experienced the warmest conditions included Scandinavia and sections of Antarctica, as well as parts of North America, Europe, Eastern Asia, and near the Greenland environment. Zonally, and so this is what we're looking at here is a zonal map, a zonal graph, which shows temperature departures based on latitude. So for example, if you're looking at the equator, it was about 0.5 degrees Celsius above the climatological average. And if you're looking at the near polar zone, it was getting close to 2 degrees Celsius in the northern polar region, but the southern polar region saw the highest above average temperatures from a zonal perspective. Now, this is consistent with polar amplification, where under human-forced climate change due to fossil fuel and greenhouse gas emissions, the poles tend to warm up faster than the lower and middle latitudes, and during wintertime, for various hemispheres, the polar environment warms considerably relative to average wintertime temperatures prior to the warming event. And this is exactly what we're seeing in the southern hemisphere for May. That southern hemisphere is heading into winter in May. It's not yet winter time, but it's starting to experience near winter conditions. May is basically the southern hemisphere corollary for November in the northern hemisphere. And despite a shift to summer, which tends to moderate polar amplification effects, we saw rather intense warmth over the polar region during May in the northern hemisphere. Now, primary impacts with regards to this warming include polar amplification, very warm temperatures over the land climate zones in the northern hemisphere middle latitudes, and a receding La Nina in the equatorial Pacific. Now, La Nina, and I'm going to switch to a sea surface temperature anomaly map for early May. La Nina tends to cool the waters in the equatorial Pacific, particularly in the eastern equatorial Pacific. And as we can see, there's a signature of some cooler than average waters during early May, but as we can see, these cooler than normal temperatures are fading. Now, this does have an atmospheric impact in that because the Pacific Ocean zone is so large and so many strong winds blow across these zones, it tends to have a global effect on a short-term basis, meaning 1 year, possibly 2-year basis. So during years where we see La Nina, it tends to pull the global average a bit lower, and when we see El Nino, it tends to pull the global average a bit higher. And as a result, if you overlap this with the global warming trend, you see the La Nina years kind of backing off a little bit, and you tend to see the El Nino years as testing new records. And this is what we've been seeing for 2017 and 2018, in that we have seen La Nina and the amazing global temperature records that occurred during 2016 were slightly moderated during those La Nina periods. Now, what's happening in the equatorial Pacific now is that it's warming up. I'm shifting to the present anomaly map for the region, and this is a GFS model. And as we can see, the surface temperatures of the equatorial Pacific are starting to warm up, and we're getting into more of what is called a El Nino, La Nina, or an ENSO neutral type state. And this will tend to result in temperatures warming up a bit versus the La Nina periods. And what NOAA is showing is that El Nino is 65% likely by this winter. So what we should tend to see in the NASA measure is that global temperatures would tend to warm up a bit if we do move into a transition toward El Nino, and we could see by 2018 temperatures that start to challenge the new records that were set in 2016 if the predicted El Nino does emerge. So that's a general overview of the situation and a bit of an understanding of our expectations based on the present NOAA forecast.